In geometry, an equilateral triangle is a triangle in which all three sides are equal. In the familiar Euclidean geometry, equilateral triangles are also equiangular, that is, all three internal angles are also congruent to each other and are each 60 degrees. They are regular polygons, and can therefore also be referred to as regular triangles. Principal properties. Denoting the common length of the sides of the equilateral triangle as a, we can determine using the Pythagorean theorem that the area is, the perimeter is, the radius of the circumscribed circle is, the radius of the inscribed circle is, or the geometric center of the triangle is the center of the circumscribed and inscribed circles, and the altitude from any side is. Many of these quantities have simple relationships to the altitude of each vertex from the opposite side. The area is, the height of the center from each side is, the radius of the circle circumscribing the three vertices is, the radius of the inscribed circle is. In an equilateral triangle, the altitudes, the angle bisectors, the perpendicular bisectors and the medians to each side coincide. Characterizations. A triangle ABC that has the sides A, B, C, semi-perimeter S, area T, x radii Ra, RB, RC, and where R and R are the radii of the circumcircle and incircle respectively, is equilateral if and only if any one of the statements in the following 9 categories is true. Thus these are properties that are unique to equilateral triangles: sides, semi-perimeter, angles, area, circumradius, inradius and x radii. Equals Sevians. 3 kinds of Sevians are equal for equilateral triangles. The 3 altitudes have equal lengths. The 3 medians have equal lengths. The 3 angle bisectors have equal lengths. Coincident triangle centers. Every triangle center of an equilateral triangle coincides with its centroid, and for some pairs of triangle centers, the fact that they coincide is enough to ensure that the triangle is equilateral. In particular, a triangle is equilateral if any two of the circumcenter, incenter, centroid, or orthocenter coincide. It is also equilateral if its circumcenter coincides with the niggle point, or if its incenter coincides with its 9-point center. 6 triangles formed by partitioning by the medians. For any triangle, the 3 medians partition the triangle into 6 smaller triangles. A triangle is equilateral if and only if any 3 of the smaller triangles have either the same perimeter or the same inradius. A triangle is equilateral if and only if the circumcenters of any 3 of the smaller triangles have the same distance from the centroid. Points in the plane. A triangle is equilateral if and only if, for every point P in the plane, with distances P, Q, and R to the triangle's sides and distances X, Y, and Z to its vertices. Notable theorems. Morley's trisective theorem states that, in any triangle, the 3 points of intersection of the adjacent angle trisectors form an equilateral triangle. Napoleon's theorem states that, if equilateral triangles are constructed on the sides of any triangle, either all outward, or all inward, the centers of those equilateral triangles themselves form an equilateral triangle. A version of the isoperimetric inequality for triangles states that the triangle of greatest area among all those with a given perimeter is equilateral. Viviani's theorem states that, for any interior point P in an equilateral triangle, with distances D, E, and F from the sides, D plus E plus F equals the altitude of the triangle, independent of the location of P. Pompou's theorem states that, if P is an arbitrary point in an equilateral triangle ABC, then there exists a triangle with sides of length par, PB, and PC. Other properties. By Euler's inequality, the equilateral triangle has the smallest ratio R of the circumradius to the inradius of any triangle. Specifically, R equals 2. The triangle of largest area of all those inscribed in a given circle is equilateral, and the triangle of smallest area of all those circumscribed around a given circle is equilateral. The ratio of the area of the incircle to the area of an equilateral triangle is larger than that of any non-equilateral triangle. The ratio of the area to the square of the perimeter of an equilateral triangle is larger than that for any other triangle. If a segment splits an equilateral triangle into two regions with equal perimeters and with areas A1 and A2, then if a triangle is placed in the complex plane with complex vertices Z1, Z2, and Z3, then for either non-real cube root of 1 the triangle is equilateral if and only if given the point P in the interior of an equilateral triangle. The ratio of the sum of its distances from the vertices to the sum of its distances from the sides is greater or equals to. Equality hold when P is the centroid and is less than that of any other triangle. This is the Erdos-Mordell inequality. A stronger variant of it is Barrow's inequality, which replaces the perpendicular distances to the sides with the distances from P to the points where the angle bisectors of APB, BPC, and CPA cross the sides. For any point P in the plane, with distances P, Q, and T from the vertices A, B, and C respectively. For any point P on the inscribed circle of an equilateral triangle, with distances P, Q, and T from the vertices. And for any point P on the minor arc BC of the circumcircle, with distances P, Q, and T from A, B, and C respectively. And moreover, if point D on side BC divides PAR into segments PD and DAR with DAR having length Z and PD having length Y, then which also equals if TQ, and which is the optic equation. There are numerous triangle inequalities that hold with equality if and only if the triangle is equilateral. An equilateral triangle is the most symmetrical triangle, having three lines of reflection and rotational symmetry of order 3 about its center. Its symmetry group is the dihedral group of order 6d3. Equilateral triangles are the only triangles whose Steiner ellipse is a circle. Equilateral triangles are found in many other geometric constructs. The intersection of circles whose centers are a radius width apart is a pair of equilateral arches, each of which can be inscribed with an equilateral triangle. They form faces of regular and uniform polyhedra. 3 of the 5 Platonic solids are composed of equilateral triangles. In particular, the regular tetrahedron has 4 equilateral triangles for faces and can be considered the three-dimensional analog of the shape. The plane can be tiled using equilateral triangles, giving the triangular tiling. Geometric construction. An equilateral triangle is easily constructed using a compass and straight edge, as 3 is a Fermat prime. Draw a straight line, and place the point of the compass on one end of the line, and swing an arc from that point to the other point of the line segment. Repeat with the other side of the line. Finally, connect the point where the two arcs intersect with each end of the line segment. An alternative method is to draw a circle with radius r. Place the point of the compass on the circle and draw another circle with the same radius. The two circles will intersect in 2 points. An equilateral triangle can be constructed by taking the two centers of the circles and either of the points of intersection. In both methods, a byproduct is the formation of eschacopicis. The proof that the resulting figure is an equilateral triangle is the first proposition in Book 1 of Euclid's Elements. Derivation of area formula. The area formula in terms of side length can be derived directly using the Pythagorean theorem or using trigonometry. Using the Pythagorean theorem, the area of a triangle is half of one side times the height h from that side. The legs of either right triangle formed by an altitude of the equilateral triangle are half of the base A, and the hypotenuse is the side A of the equilateral triangle. The height of an equilateral triangle can be found using the Pythagorean theorem, so that substituting h into the area formula r gives the area formula for the equilateral triangle. Using trigonometry, the area of a triangle with any two sides or a b and an angle c between them, as each angle of an equilateral triangle is 60 degrees, so the sine of 60 degrees is. Thus, since all sides of an equilateral triangle are equal, in culture and society, equilateral triangles have frequently appeared in man-made constructions. Some archaeological sites have equilateral triangles as part of their construction, for example Lepenskiva in Serbia. The shape also occurs in modern architecture such as Roundhurst Mall and the Jefferson National Expansion Memorial. The flag of the Philippines, the seal of the President of the Philippines, and the flag of Junkeropolis contain equilateral triangles. It is a shape of a variety of road signs, including the yield sign. Tau Kappa Epsilon NIC. Disambiguation needed. Fraternity uses the equilateral triangle as its primary symbol.